Yeah, it's good Zoom, it is.
Yeah, I only enlarged the font on Notepad, I must say.
Is the previous session still running at the moment, is it?
No, it's for our channel, it's actually running the demo or the pre-recording that your session is next, and we have 3.5 minutes to roll on the session. So
fair enough.
Yeah. There will be a delay at the beginning before it gets right. There's a caching period, so before we start talking. I should definitely remember to unmute the live feed, because once we start broadcasting, there is no audio. Yeah, so I got confused on the previous one. I must say, it's caught me by surprise. Yeah,
it's okay.
Okay, so Vladimir, I will announce Pete, and then
sure.
Yeah. Do you want all three of us to be in the session, or?
No, we can go ahead as you want.
Yeah, okay, I'm fine with both. So we're co-hosts.
Yeah.
We could do some jokes and everything. Right?
I'd be happy with that. Like a podcast, a vodcast.
Yeah, well, I never like my voice. When I hear my the recording of my voice, I get chills. It weirds me out.
Yeah, I think it's the same for a lot of people, but I've listened to so many, because I used to be in a band as well back in the day. And so I've listened to that back for years, and then having done quite a lot of public speaking and listening to that back in the recordings and stuff that I put on YouTube. And yeah, you get used to it a little bit, but yeah, you do sound completely different to how you think you sound.
Yeah, it's yeah. For me, sometimes it's disturbing, especially if I hear the recording somewhere. It's like, oh, is this me?
Other people have got to listen to that.
Yeah, well, yeah, I had the discussion the other day when I'm doing some recordings for a training and talking about offline address book and exchange stuff. And I got a comment from the guys editing, said, you need to be more, what was the word? Excited.
Okay.
Okay, you're telling me this, or the Microsoft guys is telling you this from marketing, because getting excited about offline address book or something like that, well, it's something people know and they're expecting you to give them the pointers, not the excitement around the offline address book. But yeah, so it can be a language barrier as well. So
true.
Ask them to explain exactly what they mean by more excited.
Yeah, jumping up and down. Going, developer.
Yeah, I've seen that on stage being done. So I used to work for Microsoft, and I saw on one of the internal events, but that's salespeople. That's not technical people. Yeah. That doesn't fly with us techies. It's like, what?
Yeah. People start leaving.
Yeah, well, yeah. I was sitting next to a bunch of British guys. That was my first internal technical Microsoft event, the Tech Friday. And they said, okay, we're going to play bullshit bingo. I said, what's that? So you put up a list with excited and all its variants, maximum 10 words and combos, and say, okay, whoever scratches all of them, jumps up, yells in the room, bullshit bingo, and then runs out of the door before the guys catch it. So we have 5 seconds, so let's prep.
I like it. So are we ready to start? We're live.
Okay, so welcome back to channel 2, the English set of sessions. So I'm here with Pete. He's a freelance consultant, all-around Microsoft MVP. He's a plural site author. He's one of the IoT guys, the go-to guys in UK. Yeah, he's the STEM ambassador, and he has a taste of gadgets. So Pete, the floor is yours. I'm gonna fade out a little bit and see you later.
Awesome. Hey everyone, thanks for tuning in. Obviously, you should be here for my talk on .NET Core with the Raspberry Pi. If you're not, then just stay anyway, because it should be good. So a little about me. I'm a Microsoft Azure MVP, which was mentioned earlier, and a newly minted plural site author. I haven't actually created any content for them yet. COVID got in the way. But aside from that, I also organise a few meetups. They're all virtual now these days, but when we're in the physical days, they're based in and around Nottingham. So I run NOTS IoT and co-organise .NET NOTS and NOTS Dev Workshop. And I'm also a board member of another high-tech group called LATI, which is based in Loughborough. I'm also a STEM ambassador, and that's kind of driven by the fact that I've got 2 young girls at home. And I do see that there's a need to perform a role there so that we can get more women and marginalised minorities into STEM subjects. Really important and quite core to what I do and why I do a lot of this. So what are we going to be doing today? We'll talk a little bit about the .NET framework and where that stands at the moment. And then we'll look at .NET Core 3.1 before moving on to a brief summary of how to install .NET Core on a Raspberry Pi. And then we'll spin up a couple of Hello World apps, firstly on the PC, and then we'll move on to the Pi itself. And then we'll do some proper IoT stuff with that, with some apps on the Pi, and then we'll hook a whole lot up to Azure. And all this will be live, so we'll be crossing our fingers that all of this works. And if we get enough time afterwards, I'll even show you Blazor running on the Pi and how well that runs. So .NET, and what is that and where does that stand at the moment? So it's basically a framework that lets you create apps for anywhere from desktop through mobile and IoT, luckily for this talk, all the way through to AI. And you can obviously program in C#, F#, and Visual Basic as well. We're going to be concentrating on C#. Where did .NET come from? It's been around for a good long time now. I mean, you could say 18 years, but the betas were out a while before that too. But the V1 of .NET Framework and Visual Studio .NET was released back in 2002. Stuff happened between then and 2007, but we got .NET Framework 3 and WPF, which I really liked. To be able to move away from those classic Windows Forms apps to something that looked a little bit better was nice. In 2012, we got Link and Async along with .NET Framework 4.5. And then in 2015, we got .NET Framework 4.6.2 and Visual Studio 2015. And then the year after, in 2016, we got the first version of .NET Core. And I think there was quite a lot of misunderstandings with how well released that was. And I think in the early days, there was lots and lots of breaking changes. And I think Microsoft did some learning with that. In 2017, well, we got VS 2017 and .NET Framework 4.7. And then in 2018, we got .NET Core 2. And this was really when I started looking at .NET Core, because I'd kept up pace with V1 and seeing what was going on with that. But there was a lot of sticking points the whole time. And .NET Core 2 was a reimagined way of doing things. So that was a good place to start. And then all the way up to today, we've got .NET Framework 4.8 and .NET Core 3.1 and Mono 6.8 and Visual Studio 2019. So there's quite a lot that's happened over the years and a lot of evolution. And Microsoft have tried to tidy that up a little bit. So before we had something called .NET Standard, we had base class libraries, core libraries, and mono class libraries. And they sat underneath the .NET Framework, .NET Core, and Xamarin. And you go backwards and forwards between each of these, and there'd be version problems, compatibility issues, and it got a little hard to handle. So Microsoft decided that they'd replace these disparate base class libraries with one standard .NET library, a library to rule them all. And then you can now just develop all your applications on top of a standard. And a good way to think about that is to look at this amazing table. But you can see across the top there that we've got the versions going from 1 to 2.1. And then if you run down the sides, you can see which versions of each different framework are compatible, are synchronized with that version of .NET Standard. So we can see over here on the left-hand side, from version 1 that we've got .NET Core 1 and .NET Framework 4.5 down to Mono at 4.6, and then the UWP platform at 10. And then over on the right-hand side, far right, 2.1, we've got .NET Core 3.1 and Mono 6.4 and Xamarin for Android, say, at 10. Now, what this means is, really, if you're going to be developing a desktop app or some sort of a front-end app, then you should be trying to target that highest version of .NET Standard because you'll get all of the goodies. But if you're developing a library that you want to be consumed by the vast majority of different applications, then you need to be targeting the lowest version of .NET Standard you possibly can. And that's because there's backwards compatibility, but not forwards compatibility. So something that targets .NET Standard 1 will be able to be consumed by something that's targeting .NET Standard 2.1. So that's just one way to think about it. You can find some more information on that link below. So .NET Core. Wikipedia describes it as a free and open sourced framework for Windows, Linux, and macOS. So open source and cross-platform successor to .NET Framework, and that's really what they were going for there. So it's highly performant, and the version we're talking about today, version 3.1, this is the long-term support. So we can use that in production. It's perfectly fine. And this at the moment, unless you're going to go cutting edge and look at .NET Framework 5, is the only place you're going to be able to do C# 8 and F# 4.7 as well. You can even build WPF and WinForms apps for Windows 10 on there now. And luckily for us, it also supports Raspberry Pi. So .NET Core is part of a push by Microsoft to target open source, and it's a really good thing they've been doing. But actually, they've been doing it for a good long time. Back in 2001, they sat in a cold, dark room with the likes of HP and Intel and came up with this ECMA standard to be able to open the platforms so that you could develop on your favorite language and target any platform you liked. In 2002, the first version of .NET was released, as I mentioned before, but also the Mono project began. And then in 2008, we got ASP.NET MVC, and that was an open source web platform, which was a bit of a watershed moment for Microsoft there. Then in 2014, they open sourced the .NET compiler, which was incredible. And they also created the .NET Foundation at that same stage. And then in 2014, they began work on the .NET Core cross-platform project. And then 2016, they brought Mono into the new .NET Foundation. Well, not so new in 2016. And then 2017, as I mentioned, we got .NET Core version 2. And then in 2018, we got .NET Core version 3, a preview of that. What that included was WinForms and WPF. So essentially what had happened at that point is that Microsoft had open sourced its core framework there. The WinForms and WPF stuff was highly private to Microsoft before that point, and to open source that was a great moment. And then today we're up at .NET Core 3.1. I mentioned earlier that it was highly performant, and just to give you an example of that, Raygun, they moved from Node over to .NET Core, and they were able to go from 1,000 requests a second to 20,000 requests a second just by doing that move. And they're obviously not the only people. Stack Overflow, I think, are able to serve thousands and thousands of page loads from, I think, 7 servers. And you know, obviously, how big Stack Overflow are. I've unashamedly stolen this slide from the two Scots presentation at this year's build. So if you want to watch that presentation, then do go ahead and find it on YouTube. It's a really good, fun interview they do with each other, so it's dead good. But one of the biggest takeaways is that it's the #1 most loved framework on Stack Overflow, which came out in their 2019 survey. And then, as I mentioned before, it's 7 times faster than Node.js, obviously depending on what you're doing. Something I found interesting was that 40% of new people to .NET are students as well. So that really bodes well for the future. They're going to take that from colleges and universities into industry, and hopefully bolster that side of things. So that's pretty cool. So enough talking about .NET Core. Let's have a quick look at it. So I have got a command prompt open here, and I've got .NET installed. And if you do a .NET --info, then we can see some details about the version of .NET that I've got installed. So it's going to zoom in just a little bit more so we can guarantee you can see it. But you can see here that I've got 3.1.302, which is the latest version of .NET. And I've also got the ASP.NET bits and bobs installed in there too. So to create a new console application, say, I'm just going to start by creating a directory for that. And then in there we can do .NET, new, and we can do console. And then that will scaffold us up a really basic console application. So we're restoring whatever packages that needs. And the restore is completed, and that should be about it. And then we can do .NET run, and we get hello world. We do, eventually. It has to build it, of course, first. There we are, hello world. I think my virus kind of got in the way. So there's not much to this app at the moment. If I do code dot, open that up. And then we open up program.cs, we can see what's actually in there. And yeah, I mean, it doesn't get much more simple than that. So we're just pulling in system here with that using statement and spitting out hello world. So, you know, there's not much to that. But you don't want to see me do this all on Windows. That's just not what we want to do. So I have set up my Raspberry Pi to do this. Now, interestingly, that Windows demo, you don't actually need to do it at all on your PC. Say that you've got some systems that won't allow you to install .NET Core for some reason, then you can actually run this online. You can get used to the new features in C#8, and you can do that if you go to www.net, if you like, tongue twisters. Then there's an in-browser tutorial there, and you can get going with some of those new features. So that is pretty cool. But what I've got here is Putty, which is an SSH client. And I've SSH'd in, I've dialed into my Raspberry Pi, and I'll show you that shortly. And I've created a Samba share on there as well, and I'll talk about that briefly later as well. But I've also got .NET installed on here. So if I make a directory in here as well called console1, and just to be sure, I can do .NET --info again, and we scroll up, and again, we've got version 3.1.302. So obviously made sure that I had all the latest versions installed on here before I did this demo. And just like on the Windows version, we can do .NET new console. And that'll do exactly the same thing. It'll restore the packages it needs, not very many. And then we could do .NET run. And this is a Raspberry Pi 4 I'm running this on. So, you know, the most powerful one you can get at the moment. And it's quite performant, actually. It's not bad. You'll see that this runs pretty much the same speed, if not because of less avast, slightly faster than the PC version there. So, as I said earlier, I've got Samba sharing set up, which is what we can see here. So, if I zoom in a little bit, you can see that I've got a few directories, but console1 is the one we're interested in. And if I go into console1, then we've just got the CS proj file and a program.cs. So I can open this whole directory in code. I'll let that open up. And the program.cs will be exactly the same. So, you know, I've just proven there that the .NET framework the .NET Core rather is installed on my Pi and running correctly, which is good. But we've not done any IoT at all at that point. So I'm not going to make you sit there and watch me live code. But one of the things we're going to need to do is add a library. But before we do that, let's just talk a little bit about .NET Core on the Pi To install .NET Core on the Pi is actually relatively complicated, and this GIF you can see scrolling through the screen is all of the steps to install it and spin up a Hello World application. And I've got a blog post there, and you can read it, and you can go through all of those individual steps if you really want to. However, setting it up just got too laborious for me, so I've actually created a script to do that. But here are the steps you go through before you do the script. You do an update and an upgrade. Obviously, that's the first thing you always do on a Pi before you do anything. But you need to download some prerequisites. Download the .NET Core binaries and the ASP.NET Core runtime. And then we need to make a directory that's available to our user anywhere. And we need to then extract those binaries and runtimes into that directory. And then we need to link that directory into our own account. And then that's great. That links one time, but every time you reboot the Pi, it doesn't stick. So you have to add a little bit to your .bash file so that it does that link every time you start up. And then you can check it works with .NET --info. Now, when you read it on the blog page, you'll understand the reason why I just came up with one single line that you can run. And so I've got an install script in a GitHub repo there, and you can just run that installer there directly, and it'll install all of those bits for you automatically, do all the linking, and you just reboot your Pi and .NET is installed. So I've had some feedback from some other people that have done that too, and it all seems to work okay. So we've already shown you the .NET Core console app, but we need to talk a bit about GPIO first. If you don't know, GPIO stands for General Purpose Input Output. So that is all of the I/O, all the inputs and the outputs and serial ports and stuff on the Pi. I've hooked up a little circuit to my Pi there with a button and an LED. There are actually two LEDs in there, but we'll ignore that for now. And I've hooked up pin 10 to my LED and pin 26 to my button, and that'll become important later. Now, there are actually two different board numbering schemes you can use with the Raspberry Pi, and you can see them here on this diagram. The closest numbers here to the pins is called the board numbering scheme. And the pins go 1, 2, 3, 4, 5, 6 across the pins, as you can see, all the way down to 40 at the very bottom. The alternative are these numbers, the BCM numbers, which are referencing the BCM chip on the Pi. Now, I far prefer using the board numbering scheme because I can count. With the BCM numbering scheme, you've either got to remember what pin's what or use a diagram like this to convert between a board number pin and BCM pin, and let's just not do that. Now, we're going to need a library to be able to talk to these pins, and we use the System.Device.GPIO package. And that allows us to not only access the basic I/O, but it gives you access to SPI, PWM, and I2C as well. But it not only supports the Pi, it also supports the BeagleBoard, Hummingboard, Odroid. I've not played much with those boards, to be fair. I tend to spend most of my time in the Raspberry Pi. Not only does it support Linux in this way, but you can use it on the Windows 10 IoT flavor as well, which is like a stripped-down version of Windows 10 that gives you the facility to run WPF apps and IoT apps on a Pi, which is quite cool, but I don't know how well supported that is these days, to be fair. This package, you can install it either via the CLI, which is what we'll be doing, or if you're in Visual Studio, you can use the package manager. You can find out a little bit more about that package from that link if you like. Now, there's also a set of device bindings which are going to help you getting started with chips. So you can download a whole heap of somebody else's code and then start talking to I/O expanders and temperature and humidity sensors, and the Explorer hat for the Pi. If you've seen that, that's pretty cool. And the Sense hat, the one that's on the Pi up at the Raspberry Pi and the Pi on the space station. So yeah, somebody has done you some work there already that you can use, and you can find some information about that there. And I've got a link to the GitHub repo for that too. So we need to use this. So we need to make an LED app. But the first thing we need to do is actually install that GPIO library. So if I flick back to my console application, I can do .NET add package System.Device.GPIO, and those caps there, they're important. So remember that. So we'll install that package. And that's telling us that it's added it to our CS proj file. So if I return to our application in VS Code and go to our CS pod file. Now we've got System.Device.GPIO living in there happily. So that's great. That's the first start, but we need to actually drive an LED here. I'll pull this down a little bit now. And again, I'm not going to make you watch me code. So I've got some code and I'll just explain how it works. So up at the top, we're using the System.Device.GPIO library here. And I'm also importing the System.Threading library because I'm going to be turning an LED on and off. And I want a delay in between those two things. Otherwise, you're just not going to see anything. These red squigglies are because I'm opening this project directly from the Pi, and the C# extension doesn't quite know what to do with that. But we'll get around that soon, spoiler alert. So inside our main here, we've got a new GPIO controller. And you can see I'm passing in this pin numbering scheme of board, which is what we mentioned earlier. So you could pass in BCM there if you really wanted to. And this GPIO controller is what we're going to be using to control the I/O on our Pi. I've left the hello world in there because if nothing happens, then you're not going to know even if your app's running properly. So I kind of just leave something in there just to say something's going on. Then I'm setting up a couple of variables, and we're starting with the pin, the LED pin, and I've connected that to pin 10, as I mentioned earlier. And then I've got a light time, and that's just how long I'm going to turn on and off the LED for. And that's going to be in milliseconds, so just 300 milliseconds each. And then here I'm opening a pin, and it's my pin here for the LED, and I'm setting it as an output. And then in this try, because we're good programmers and we don't want things to crash, I've just got a while loop, so it's just going to sit there forever, and it's going to use this controller.write, and that's the method we're going to use to be able to drive a pin high or low. And we use pin value.high to go high, and then we wait here for this 300 millisecond delay, and then pin value.low will turn the LED back off again, and then we wait again and go round in a loop. And then when the whole thing finishes, again, we're good programmers, so we actually close the pins so you can use it elsewhere. So if I now flick back to my console app, if I do a .NET run, and I've got a camera set up that's pointing at my Pi with that same circuit, and we just give it the requisite amount of time to build. And we cross our fingers, of course. You're crossing your fingers. Let's have a look. Oh, did I save it? Is that what I did? Nobody reminded me of that. It does help if you save those changes. Try that again. Then I run. Yep, that is live. Ooh. We should have a flashing LED. But we don't have. Why do you think that might be? Let's have a look, shall we? It is actually running. It's not good when the first demo doesn't work. Let's just do that again. Oh, did I? There's me leaning over to see that in behind. Oh, my LED's not running. Oh, I'm disappointed. Now we have to live fix this problem. So let's just make sure that we've got everything we need. I am going to get rid of that. Yeah, so that definitely should have been doing something. It wouldn't be a live demo if it didn't work, yeah? So that's back to our original project. We can install the package, the GPIO package. And that's done. Our code in there. Oops. Which is here. There's nothing wrong with that whatsoever. That should work. Saved. I wonder if it's because it ran the last one. I don't know. Oh, and my LED isn't flashing. All right, I'm not going to force you to do that. Trust me, it does flash. We'll move on, and I'll come back to that if I can. So that was how to flash an LED. Sadly, it didn't flash. I'm not sure why, but we'll ignore that. But what we don't want to do is exactly what I'm doing there and developing everything on the Pi. So we can actually set our system up so that we can remote deploy the code to the Pi directly from our more powerful, in this case, my Surface Pro, down onto the Pi, and then run and debug it directly from VS Code on our PC. And that whole workflow is just far better. We don't really want to be opening up Samba shares and things like that. And there's a couple of different ways to do this. And I couldn't get one of them to work, which is you can use a remote SSH plugin extension for VS Code. And that is, if you can get that to work, that's fantastic, because that does a lot of the stuff that I had to do for you. And just to give you a bit of a recap, I've got the circuit set up here with pin 10 for the LED and pin 26 for my button. So if I flick over to Explorer over here, I've got a few apps that I've made previously, and I've got a button app here. I'm just going to close this out of the way. And open this up in code. And I'll briefly talk about how I've got this set up. But I've got a blog post that takes you through how to get this all set up, actually. But I'm not going to spend too long going through it because we haven't got a massive amount of time. But we have a launch.json here. And what this is going to do is it's going to attach to a debugger that we've got installed, the MS debugger that we've got installed on the Pi. And it's going to do that through an SSH tunnel, a PuTTY SSH tunnel. So it can spin up the debugger process and connect to it over SSH, which is quite useful. But before it does that, it has to copy some files over there onto the Pi. So it uses rsync to do that. I couldn't get rsync to work from Windows, so I'm actually using WSL to do that. But I'm sure there's a way we can get that to work from Windows. What we're going to be doing before that, though, is using this .NET publish, and we're going to pass in Linux ARM to it to make sure that it's going to build Linux binaries. Otherwise, it's going to build Windows binaries, and they're not going to work. And then before it does that, it's going to do a regular build as well. And then, yeah, once all that's done, then the files will be on there, and it'll spin up this session on the Pi and start debugging. So just very briefly, you can see the code that I've got for the button. I've taken away threading because I've got no delays, but I've left the GPIO in there. I've still got a controller, but I've added a button pin, and I've connected that to pin 26. And now I'm opening that button pin, and I'm telling it to use a pull-up, an input pull-up. And so what that means is when you connect one side to the Pi, you connect the other side to ground, to 0 volts. And if you don't press anything, then inside the Pi, it's going to pull it up to a high level. And when you press the button, it's going to drag it down to a low level. If you didn't use input pull-up, you'd have to put your own pull-up resistor on there to get that to work. My while loop is similar, only I am going to use controller.read to read my button pin. And if the button pin is false, I remember what I said, if you press the button, then it drags it low. If the button is false, then we are going to set the LED to be on. Otherwise, else down here, we're going to set the LED to be off. And again, we're going to close the LED pin after we finish with it. So instead of going through the rigmarole of doing this all on the Pi, we can now actually do this straight from my VS Code session on the PC here. So this is that task that I was showing you earlier, and I can run that. I'm just going to make sure that this isn't running. That's good. That's not running. Right, you can actually see how this is going to work, actually. So we've got our console app there at the minute. And then I switch back to VS Code, in fact. See some things happening here. So it's restored the project. That's finished. And then it's executed the publish task here. So it's creating our Linux binaries. It's happy with that. And here's the part where we're going to use rsync to copy the files. And you can see here now the files are being copied over. And these are just .NET Core DLLs that are being copied over there. So I can actually see now over here that we have an RPi button directory. So that's going to copy all of them across. Now, what rsync is good at is that it only copies the files it needs. So if all of those files already exist, it recognizes that, and it skips copying any files which don't need to be replaced and only copies the new updated files. So you can see that took a while, but a lot of that I don't update. It's only my project I'm updating. So it's finished copying them. And now we switch over to the debug console. I'm just going to pull that up a little bit, and we can see we have Hello World sitting there. So let's just see if this is really broken. Oh, look, see, that does work. I'm not entirely sure what's going on with that, why that broke, but it does work. You see that? An LED actually turns on and off. So, yeah, I don't know why that flash didn't work, but I'm not bothered because the next part works and it's all good. So it's practically the same code as the LED code anyway. But what we can do, if I switch back to VS Code and stop that, we can actually put breakpoints in here and then stop and inspect the code. So if I run this again, you'll be able to see the difference this time in what it actually deploys. So we're doing the build. And restoring whatever it needs to do. That was weird. I don't know why the first demo didn't work, but apologies for that. These things always seem slower when you're demoing, especially when you've got 12 minutes left. And this is where we're going to publish the Linux ARM binaries. So it doesn't mean it's publishing them to somewhere. That just means that it's creating them, of course. It's the rsync task that's doing what I'd call the publish at that point. It's happy with that. And now it's going to do the rsync, and you'll see that this will be a lot faster. So it's only just needed to copy a couple of files there. Hello world. Now, if I press my button, then there we are, and we've stopped. And it's even then going to pull in the variables we've set up. So you can see pin 10 for the LED and pin 26 for the button. So I'm not going to go too far into debugging, but I mean, that gives you a far better development environment now. And debugging anything with IoT is intrinsically difficult, but this really does get you over that first hurdle there. So that's pretty cool. But what we've done at that point is really we've demonstrated the thing of IoT. There is no internet in any of that, of course, unless you class the local network I'm debugging over. So what we can do is hook the whole thing up to Azure. And I've got a couple of demo projects. And again, I'm conscious of time, so I'm not going to go into too much detail with them. But if I flick back to my examples here, then I've got one I've got set up here called Pi IoT Hub out. And in fact, let's just close this so I don't confuse myself. I'll open this in code. And very briefly, I'll just explain what's in here. So we've got a new Microsoft Azure Devices.client library that we've imported. And there's a connection string, which I'll show you in a minute. And then we create this new device client. And this is what we're going to be using to do all of the communication up and down to Azure. A little bit further down, we're going to create the new device client, and we're going to pass in the connection string from earlier. And the connection string is how we're going to securely connect up to the IoT Hub. I've left the GPIO controller, and I've added button press direct variable here, and that's going to let me know whether or not I've got the button held down or not, because when we send a message to the IoT Hub, we don't want to send hundreds and hundreds and hundreds of them when you've got the button pressed down. I just want to send one. So that's what that's doing there. And then in this while loop now, all I'm doing is if the button wasn't pressed before, we tell it is pressed, and then we use this send cloud to cloud message async routine that I've written down here. This is the message I'm going to send up to IoT Hubs now. It needs encoding correctly as ASCII and then as a byte array. So that's what you need to do to any message that you send up there, is just encode it correctly, otherwise it's not going to accept it. I'm actually adding some properties, and you can use those to route messages from IoT Hub out to things like Logic apps and stuff like that. And then I actually send the message there using the device client.send event async. And then I just say that I've actually sent it. So I've got the same remote debugging set up. So I'm just going to start that. Now, I've not really got enough time, but you know, IoT Hubs, there's so much information out there that you can just go ahead and look for yourself. But I have downloaded this Azure IoT Explorer app. You can see there, and this allows you to test IoT Hubs. So it's going to act as a way of being able to grab the messages, look at the message traffic that's going across the IoT Hub, and then intercept that. But it also allows you to do some other stuff too. Now that also needs a connection string, slightly different connection string, which I've grabbed from my IoT Hub setup, and I can connect that. My poor laptop is doing so much at the moment. And then that's going to list over here the various different devices that I've got set up on that IoT Hub. And surprise, surprise, the one we're interested in is this Raspberry Pi device. So we can actually see that we can get the device identity information, including the connection string that we've got pasted into our application there. But we've got this telemetry tab. And if I press start on that, then what it's going to do is start monitoring the messages on the IoT Hub. So let's just come back out of that. And this will be soon finished deploying. I use rsync and copy the files down. Faster, faster, faster. It's good to do this live. I could have pre-recorded this and chopped all of these waiting bits out, but you know, at least you can see that it's live by the fact that the first demo didn't work, at least, and having to wait for things like this. Actually, while it's deploying that, if I get the portal up, so this is where obviously if you've not used Azure before, then this is where you're going to create your Azure resources, and I've created an IoT Hub in here. Let that load. Let's flip back and check on the process. It's still going. This shared access policies blade here, this is where I grab the connection string for that device explorer. So if we go into that, then we can see shared access policies in there. And that device explorer one there is the one that I'm using for that. But if I scroll down, then we've also got IoT devices on the left. And we should see that same list. Excuse me. And there's Raspberry Pi. How's this getting on? Ah, that's finished. Scroll up and we can see our hello world. Now, if I switch back to our IoT Hub Explorer, zoom in on that. All being well, if I press a button on my Pi, then we should get a message appearing in here. There we are, body button pressed. So that's a message going from our Pi up to an IoT Hub, and we're then intercepting that on our PC. and looking at that message using the IoT Explorer there. So that works pretty well. But that's just one way. Zoom through this next bit. So if I stop that and close this, and then very quickly we go back, and I've also got a IoT Hub in project. And that can just quickly demo sending messages from the IoT Hub down to the device. This code is almost identical, so I've not got time to go through it all. But the main difference is we're calling this right at the top up here. We've got a receive cloud to device message async routine that I've got, and that is just constantly checking to see if any messages have been sent down. And if they have, then I spit them out onto the console and tell the IoT Hub that I've received it. So let me just start this up. Let that finish doing what it's doing. 3 minutes left. I'll have a tap in my ear telling me to speed up soon. Let's just go back to this a second. Yeah, so this is my Raspberry Pi here, and there's the connection string for it. And you can just hit this copy button, and then you can paste it into the code. All of this code's on GitHub, by the way, so feel free to grab it along with the instructions on my blog. So you can go and grab that. And then, yeah, you just paste it directly into that connection string location, and you're off and running. So while that's building, again, conscious of time, we just talk about what we've done so far. I'm not going to get a chance to do Blazor, although I might, while I'm taking Q&A, just spin it up so that you can actually see it. But Blazor's fab, and it runs really well on a Raspberry Pi. It was a pet project of Steve Sanderson's, and he demoed it, and the people at Microsoft went, "Oh, I need that, quick!" But it's basically a way of replacing JavaScript and switching over to C# for your web apps. So it's fab, and yeah, there is a demo for that, but we're not going to get a chance to look at that. There's some links here, if you wish, including stuff about Blazor, and then .NET Core 3.1 and VS 2019, which you should be using by now. And then that's my blog just there on using .NET Core 3.1 with the Pi, and some more information about the GPIO NuGet package, and also the IoT Device.Bindings source code GitHub repo there. So you can go and have a look at that too. If you want to get a hold of me, then Twitter's my favorite place, Pete_codes. You'll find me on Twitter. But you can also email me, Pete at pjgcreations.co.uk. If you want to find out about blogs and where I've been speaking, then that Pete Codes website is where to go for that. I also run Knots IoT, .NET Knots, Knots Workshop, and Lati. You can see in there, and the Agile Engineering podcast. I'm part of that too. So I like to keep myself busy. The slides are not online yet because, of course, you're always modifying them 5 minutes before you give us a talk. So that's what you expect. And then, yeah, you can go ahead and download those later. I'll tweet out when they're ready. But yeah, that's .NET. Go ahead and make something with it. And with that, let me just switch back to this and see where that got to. Oh, look at that, still going, but it's nearly finished. So I don't know if you wanted to take some Q&A at this point, or did you want to wait for my PC to finish deploying apps? Or
yeah, so at the time being, there is a question about the source code that you see. You already posted the GitHub links. So
yep.
Is the source code going to be available for the guys following to drill?
Absolutely, yep. If you should be able to find me on, let me have a look, do it this way. Go to github.com, and I'm PJG Pete Codes on there. So PJG Pete Codes, there we are. You can find all of that stuff in there, but I think there's a link in the slides there that you can go to, but it's all linked from my blog as well. but it's this .NET Core 3 Pi repo that you're going to be interested in, and that's got, when it loads, those same apps in there and a couple of other little bits and bobs as well, and some instructions on how to get going there, including that single line install script as well. But yeah, the blog's the best place to start, which is linked just there. Oh, what's he doing? Stop zooming out. I don't want to zoom out. So yeah, that's that. You can go and grab it from there. This is copying stuff. Is there any more questions?
No, not at this moment. I see some dots appearing, but still hasn't popped up. If you like, maybe give you a couple of minutes to show the Blazor app as well.
Definitely. Yeah.
Let's go with that one, and we'll see if something pops up.
Yep. Sounds good.
This
is virtually done deploying the IoT Hub in. So I'll just let that finish, and then I'll quickly show you the Blazor stuff. Come on now. I'll do the Blazor directly on the Pi rather than doing it this way because it's faster. The first time, anyway. You see, this is transferring quite a lot more DLLs for all of the Azure stuff that it needs, all this cryptography and stuff like that. It's virtually done now. There we go. I should switch over to debugging any second. This is also faster if you're not presenting and got PowerPoint and Slack and your webcam, 2 different webcams running and things like that. It's always a bit slower under those circumstances. So expect that to be slightly faster. So back in this IoT Explorer, we've got a cloud to device message, and I can type a message like hello VACD in there. So that's sitting in there. And if I press this send message to device button, then you can see down at the bottom of our screen we have received message, hello VACD. So that's messages going from the Pi up to the IoT Hub, and then the IoT Hub's able to send messages down to the Pi as well. So that works pretty nicely. So over on the Pi, though, if I do this, make a directory called Blazor, not in caps, and we could do .NET new Blazor. Now there's 2 different versions. There's a WASM and a server, and I'll show you the server one first. I've got just about enough time. So that's going to scaffold me up a basic Blazor server app. The difference between the two is Blazor server, as it kind of says, lives on the server, and what it does, it orchestrates the DOM changes, the document object model changes, the stuff that you can see on the screen in the browser. It orchestrates those over Signal R. So you have a Signal R process just running in the browser, and it's that process that then squirts the stuff onto the DOM. So you don't have any code running of your own on the actual browser that's running in the server. So that's what this is doing. But I can't directly run it from there, sadly. So if I go back to my Blazor here, I just open that up, and I just need to make a quick change to one of the files, because at the moment it's going to bind itself to localhost, and that means I'm not going to be able to see it from my PC, which is sad. So I need to add one single line to the program.cs file, and then I'll be able to run it. Come on, hurry up. I probably should have closed Slack. I think it's taking about 64 gig of my 16 gig of RAM. Right, so we can go to, I'm not going to go through the files because you can do that in your own time, and it's just Blazor. But to get this so that we can access it from outside the Pi, inside this config web host defaults web builder, we just need to add an extra line, which is this one, and then that's going to bind it to any IP address can now access it. So if I run this, and it'll do the same sorts of things, it'll build it up. It doesn't take all that long, actually. It's not bad. Again, having a Pi 4 really helps with this. It makes everything a lot more accessible. You try and do this on a Pi 3 and it will work, but it's going to take you probably 3 times longer to do any of these steps. It's just not really that practical. Just buy a Pi 4 and go for that. Now that's started, you see. Now if I go over to here, then I happen to know that my device is called MS Cognitive. And we run this on port 5000. My PC is deciding that now it's when it wants to be really slow. But then it's going to load up my vanilla Blazor website. And this is actually my PC being slow here and not the Pi, I'll have you know. So this is what you see if you spin up a really vanilla Blazor website. And actually, it's quite nice. I quite like it. We have a counter and in there when it loads.
Okay, quite extensive demoing, I must say, in the end-to-end presentation, Pete.
I went as fast as I could.
Yeah, okay, with the snags and everything, but it's still, I think people find it valuable as well. So unfortunately, we have to cut it close to the end now. And
that's all good.
I want to thank you for the session and everything you presented. Have a nice rest of the day. We'll continue with the streams, followed by Deploy Azure with Pulumi by Andrea Cerone. So thank you again.
Excellent.
Next time, I hope we have more time and see the light show demo as well.
Yeah, definitely.
Yeah, okay.
All right, thank you very much.
Yeah, see you around.
Cheers.
Thank you.
See you. Bye.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.